Okay, so as per our yesterday class, we have completed around about the designated port identification with the
Yes.
practice topology, and we have seen that how they are working. Okay,
Yes.
okay. Now here you can see that the port selection what we have seen here. Here we have seen that suppose this is our root switch. Okay, and
Yes.
this root switch is connected with non-root switch with a single port, right?
Yes.
Okay, here also single link, single link, single link, right? And when you have a single link towards root or towards non-root switches, so for selecting your root port or designated port or block port is little bit easier, right?
Yes.
And here, but if you have direct connection with switch, which is root switch,
Yes.
and you are non-root
Yes. You
switch,
are.
okay, and now you have two links which is connected towards root switch.
Okay.
So when you have two links, two redundant links connected towards root switch, then which link will be working as a root switch, a root port, and which link will be working as a block, right?
Yes.
So in this condition, we can see here when you are electing root port and designated port, it is possible to have a tie in a both path cost, path cost 100. See, from here also 100, from here also 100, and bridge
Yes.
ID. Bridge ID means if I am comparing, so bridge ID
Yes.
is same, even the root bridge ID is also same, and my bridge ID is also same regarding the link, right? But if
Yes.
you will
Yes.
say here, like if this switch will say that okay, if I want to go from this side, so cost is 4. If I'm going from this side, so cost is 4 4 4 4 means 16. So here
Yes.
cost is different, but here cost is same. Now you are talking about
Yes.
bridge ID.
I,
So bridge ID, this root bridge IG is different and this non-root bridge IG is different, right?
yes.
Yes. So here they are
This
saying
ID
that
is a combination of the priority and MAC address, right?
yes, yes. So here it is saying that so bridge ID is also different as same. Okay, but in our lab you have seen that the bridge ID was same.
Yes.
Oh, sorry. Here bridge ID is same and path cost is same, but in the above
Yeah.
lab you have seen that bridge ID and path cost were different, right?
Yes.
So how it is working? So if you'll see that this is the root switch, so all the ports of the root switch will be working as a designated port
Yes.
now. But here you will see that E2/0 and here it E3/0, right?
Yes.
E2/0 is connecting to my E3/0
Yes.
and E3/0 is connecting to the non-root switch which is E2/0.
Yes.
Okay, so this lab is giving you example that normally what we think that to if I'm comparing, so the first comparing is what? If I want to compare to make this as a root port, right? Okay,
Yes.
so the first comparing is what? Cost. So cost is same,
First.
cost is same. Okay,
Yes.
so cost is tie. Now bridge ID of the root switch is also same for this link also and is also same for this link also. Now what is the
Yes.
remaining one?
MAC address.
No, remaining the if I'm making suppose
Mm.
MAC is not MAC address. MAC the bridge ID is
The
the
preference.
combination of priority and MAC address.
Yes.
So what is the
Loop back.
remaining?
Loop back.
No loop back. See, suppose this is a root switch, right? So root
Yes.
switch, all the ports are in designated, no problem for that, right?
Yes.
Okay, this is E20, this is E30, no problem.
Yes.
Okay, now this switch wanted to become a root switch, so they will compare themselves, and this switch is root and this is non-root switch, right? This is done.
Yes. Yes.
Now they have to work on the link. So I
Yes,
have
sir.
two link. One is E30 and E20, right?
Yes.
Okay. So one link has to, it will work as a root port, and one link will be in a blocking state, right?
Yes.
And why blocking? Because DP, so one has to block. Okay.
Okay.
Who will block? The lower bridge ID will block his
Lower.
port, right?
Yes.
Or
Yes.
designated port. Now, but here I'm saying that here the switch 2 has two link, right?
Yes.
Okay. Now, for making this link root port or designated port or block port, okay, what are the conditions? What they will compare with the root switch to make this as a root port or designated port or blocking port? So first they compare that
Mhm.
path cost. See, if this switch, if you are here and you want to go from this path, the upper one, right, to reach
Okay.
root, so what is the cost?
100.
100. And if you want to go from this side, cost is
100 too.
100. So cost is same. So you will look for what?
Yeah.
Bridge ID of whom?
Okay.
Bridge ID of upstream switch.
Yes.
Okay, so you will say that this link will tell you that, okay, if you want to reach root, bridge ID is this one. If you want to
Yes.
reach root, bridge ID is this one. So you are getting bridge ID of your upstream switch same from
Yeah.
both link.
Yep.
Now then you have to look for the third condition. Now see here,
Yes.
now come to this one. If I am here on this non-root switch, right? Okay, now
Yes.
if this non-root switch want to make this port or this port to root port designated depending on the selection, right? Okay, so what is the
Yes.
selection first? This root, this switch will, this is a non-root switch, this non-root switch will look for root root switch, right? Okay,
Yes.
so if this switch wanted to reach root, okay, from here is 4 kilometer from this way, and
Yes.
from this way is 16 kilometer,
Yes.
right? So which one is the
Yes.
lowest? 16. So automatically
16.
this link is a root port, and this link will
Yes.
be a DP or blocking whatever, right? Is
Yes.
selected easily, right? Okay, but
Yes.
here what is saying that cost is also same.
Yeah,
Okay,
of course.
okay, and for example, from this way cost is 1 1 1 1, for example.
Yes.
So cost is equal from both side.
Yes.
Okay, so here you are saying that here is 4. Okay, I understood, but here maybe I'm using 1, I'm using 1, I'm using 1, I'm using 1. So cost is same from both side.
Yes.
Okay, now it will look for the second condition. Second condition, it will look, the first condition is cost, second condition is upstream switch bridge ID. Okay,
Okay.
okay, so for me this is my upstream. What is the bridge
Yes.
ID? This is MAC address, right?
Yeah. Of course.
Okay, now, and for me this is my upstream. Okay, because I can also
Yes.
connect from this way also and from this way also, right?
Okay.
So this
Yes.
non-root switch have two upstream switch, this one and this one. Now, so if this switch want to decide this port to be working as a root port or designated port or block port, so this,
Yeah.
then this will say that, okay, no problem, let me compare which upstream switch have the lower MAC address.
Yes.
Okay, now tell me, your MAC address is 100 and the switch 1 MAC address is 100 and switch 5 MAC address is 500, right?
500.
Okay, now
Yes.
tell me which one has the lowest?
The
The
100
upper
one.
100. So I will consider this path if the path cost is equal.
Yes.
Okay, so same here, but here path cost is also same and bridge ID is upstream, bridge ID is also same.
Yes.
Then it will look for third option. I'm explaining, you just give me 1 second.
Mm. Okay.
Okay, so as I told you that we have compared, if you, according to this lab, Okay, we
Okay.
compared first cost is equal, then we compared the bridge ID of upstream switch is the same.
Okay.
Okay, now if both is same, then what is the third one? So third one is known as link priority. So if you will come here,
Okay.
okay, and if you'll come to the switch and if you'll type so a spanning tree, you will see something like that here, some link priority, right?
Okay.
Okay, priority, this is the priority and all the link priority will be same, and this is the link number, number 1, number 2,
Okay.
number 3, number 4, like that, right? Okay,
Okay.
so now according to this lab, okay, now according to this lab, so what is the link priority of this? 128 dot, for example, 1. Okay,
Okay.
and this is for example 2. Okay, okay, and now what is the link priority of this link?
Okay.
1,
Okay.
and link priority is 2.
Two.
Okay, now when every process is same, see, they will check only three process. First is link cost. Okay, so link cost is what now is same, right?
Yes.
Second, they compared upstream switch bridge ID is this, that is also same, right? Now they will look
Yes.
for upstream link or interface priority. Okay, so by default all the link priority is 128 and there will be interface number like 1 2 3 4 like that, right? Now,
Yes.
so if this switch wanted to decide whether this port will be working as a root port or block port like that, so this switch will
Mm-hmm.
compare with the upstream. Okay, now when it is comparing
Yes.
with the upstream, so upstream has two port, E2 by 0 and E3 by 0, right?
Yes.
Okay, so now tell me which one have the lowest port ID, E2
E2
by
slash
0
zero.
or E3 by
Yes.
0?
E2 by zero.
E2 by 0, right? So
Yes.
E2 by is,
Yes.
for example, it's 128.1 and this is 128.2, right?
Okay.
Okay, now,
Yes.
so this one will become,
Root port.
and this one will become block.
Block.
Okay, it doesn't matter. Sometimes people get confused that, sir, I am 3 by 0. So it is higher, right?
Yes. Yes.
And this is E2 by 0. So this is lower. So this should be root port. But
Yes.
always keep in mind every selection regarding port, okay,
Okay.
regarding port selection, whether it will be root port, blocking port or designated port, it will be always
Yes.
defined by or decided by the upstream switch.
Okay.
Okay, see, if this upstream switch will become here 3.0, okay, and
Okay.
here will be
And
2.0, right? So this one
okay.
will become like that one. Okay,
Root
let me show
porting.
you this with the practical.
Okay.
So for example, this is 2 by 0, this is 3 by 0. So let me show you first switch 1. So spanning tree, this is a root, right? Root, all the
Yes.
ports of the root is designated, right?
Forwarding. Yes.
Yes,
Yes.
forwarding and designated. Cost also you
Okay.
can see 1 2 3 4, you can see, right? But priority is same.
Yes.
If I'm coming to
Yes.
switch 2, so spanning tree, so see, switch 2 has 3 port, 3 by 0, 3 by 0. See, 3 by 0 is root,
Yes.
but 2 by 0 is block.
Yes.
But okay, now if you will make this, this one is lower and this one is higher, right?
Yeah.
Okay, so always it depends on the
Bridge.
upstream server switch.
Yeah.
Now if you'll say that, okay, if I want to make this link 3 by 0 as blocking and 2 by 0 as root port,
Forward.
okay,
Yes.
so you have to change not on the local switch, you have to change on the upstream switch. Okay, so now let me
Yes.
come here on the upstream switch. I will say interface e e2 by 0. Okay, now
Okay.
I will say that spanning tree VLAN 1, because they are in VLAN 1, right? Okay,
Okay.
Pri port priority by default it is 128, right? Okay,
Yes.
but let me make it uh, like what,
64.
the multiple of 16. Okay, no,
Mm.
e2 by 0 is already root port, right?
Yes.
So I want to make it higher than 128. So let me make it 192. Okay,
Okay.
192 exit. And now if you'll verify with the source spanning tree, now you will see that e2 by 0 is now,
Forward.
no, that is okay. Forwarding designated root switch, all ports will be designated and in forwarding state, right?
Yes.
But I'm
Yes.
talking about the priority.
Oh,
Earlier
yes.
it,
Your priority have
yeah,
changed.
earlier it was 128, but now I
Yeah.
changed to
Now it's 192.
192. So this 2 by 0, but now
Mm-hmm.
it is 192, right? So the
Yes.
priority is higher than the lower one, right? This one, E3 by 0.
Yes. Yes.
Okay. Now if I'm coming here to this switch,
The second one, yes.
second switch, see, earlier this switch was root, right?
Root, yes.
Yeah. Why it was root? Because here they were comparing with this one, right?
Yes.
Okay. But now I change the priority to make this link to make as a root, right? Now you
Yes.
can check here, come to switch and now type here, so spanning tree. Now see, E3 by 0 is now
Yeah. Just block.
block and E2 by 0 is now root. So now what
Yeah.
happened? So this is root now and this is block now. Okay.
Yes.
So now did you understood? So everything has been decided from upstream switch. So
Yes.
now
Yes.
see, here they are comparing and here they are comparing. Okay.
Okay.
So they will say, okay, your priority is
It's
192
high.
and my priority is, so they will not compare about this one. Okay,
Okay.
like that. So they always compare about the upstream. So here they are saying, okay,
Yes.
so this is lower, but here don't think that you'll say that no, my port number is higher. Can you see here,
Yes.
port number
Yes,
is
I can
lower
see.
but the priority is higher, right?
Yes.
But here port number is higher but the priority is lower, so this selection is always based on priority.
Yes.
Okay,
The lower one is the root port.
yes. Okay, so here we have seen, so you can see here one that the bandwidth on each link is equal. Yes, of course the bandwidth on each link is equal. So both ports of the switch 2 have equal path cost towards root bridge. Yes, this
Yes.
also. Now which port will become root port on switch B? So normally in case lower bridge ID is used as a tiebreaker, but
Yes.
it is not possible here because both of the links belongs to the same switch. So for both
Yes.
of the links priority and the MAC address will be same. In
Yes.
such case port ID, see this is important, in such case
Yes.
port ID is used as a final tiebreaker and
Yes.
the port ID is consist of two components. One is port priority and port number. You can see here,
Yes.
this is port priority and this is port number. So
Mm.
priority is
Yes.
always same, number is different. Okay, so the
Yes.
final is the number. Like see, priority is same, say here by
Yes.
default priority is same, so number is the tiebreaker. So here is 1 and here is
Okay.
2.
Two. Okay.
Okay. Now by default the port priority of an interface is 128 and the lower priority is preferred.
Yes.
Okay, but if there is a tie in the priority, then the lowest port number is preferred in the selection.
Mm.
The sender port ID, not the local port ID.
Yep, the sender.
Yes, so the sender port ID will be determined as a tiebreaker, not the local port ID, or you can say local switch port ID. In the above example, switch 1 will decide whether E3 by 0 or E2 by 0 will become the root port on switch 2. Understood? E3 by 0 or E2 by 0 will be decided as a root port. Who will decide? Switch 1 will decide. Okay?
Switch one, yes.
Yeah, switch 1 will decide. If the priority is equal, the sender switch 1 port ID
Yes.
E2 by 0 from switch 1 is preferred over E3 by 0.
Yes.
Okay?
Yes.
Switch 2 due to its lower port number. So, okay?
Number.
Yes. Now, so E3 by 0 on switch 2 will become the root port. See
Root
here.
port.
Yes, see E3 by 0. So see why I have written this thing, because sometimes people think that everything depends on the local. Okay.
Yes.
Yes. Now, if you will make any changes on switch 2 port ID, there won't be any effects as port selection is based on upstream switch. Okay. So we can
Yes.
check this one and see, right?
Okay.
Okay. So let's come here. Okay. So let me make everything default. Conf t interface E2/0 spanning tree VLAN 1 port priority 128. So I made it default, right?
Okay.
So if you want to verify, so is spanning tree. So I made it default, right?
Yes.
And if I am coming to switch 2, okay, so is spanning tree. Okay, I have already did some changes here. So let me make this as default conf t interface E2/0 spanning tree VLAN 1 port priority
Priority.
128, and then you can check here. So everything is default now. 128
Yes.
128 you can see. Now as you are saying that I want to make this, okay, let's check our E2 by 0. E2 by 0 is block and E3 by 0 is my root, right?
Yes.
Okay, so you will say that no, I want to make E2 by 0 as a root port. So if I'm using that type of configuration, the interface E2 by 0, which is block here, you can see here, which is block due to the priority, right? Okay, so you will think that, okay,
Okay.
let me make this as a lowest priority. So spanning tree VLAN 1 port priority, like you will say that, okay, let me make it 64, lower, right?
Okay.
Okay, and I will tell you, okay, shut and no shut on both interface E3 by 0, shut and no shut, just to compare. Okay,
Okay.
refresh and now see E2 by 0, you are
Yes.
saying that
Root.
it is root, right?
Yes.
Okay, no problem. I just come here. Conf t interface E E2 by 0. Just, when you shut at that time, they think that no shut. Okay, now see, I change the port ID. So if you see here,
Yes.
switch to E2 by 0. Where is E2 by 0? E2 by 0. What is the priority? 64.
64.
And my 3 by 0 priority is 128, right?
Yes.
But still this this one is root. My priority is higher,
Yes.
but I am root. Okay,
Yeah.
so yeah, so here what I mean to say that always all decisions are made by upstream server, not local. So I made these changes on local switch, right? Switch 2. So whatever you make the changes on switch 2, it will not take effect.
Affected. Yeah.
Yes. Now sometime you need to shut down and no shut down the ports to accept the changes. Okay, sometime, but not every time. Okay.
Okay.
Now another interesting example, yesterday we talked on this one, but we haven't did any practical, so we'll do this one.
Yes.
So
The
in
pub
this,
one.
yeah, in this condition we have switch, in middle we have hub, and here we have switch, right?
Yes.
Okay, now here the condition is totally opposite. Now see, to
Yeah.
reach to reach root switch, cost is what? From this link same, 100.
100.
Okay,
Yes.
now upstream switch from this side is the same. Now,
Yes.
now to compare this one and this one, to compare this is the same. So port ID is also same of upstream server. See here, if I'm talking
Yes.
here, see, we talked on this one, right? So link cost is
Yes.
also same. Upstream switch
Uh-huh.
bridge ID is also same, and upstream interface priority is also same.
Yes.
So in this condition, what we can do? So let me come here. If let me open the lab. Okay, so I on that. Okay, so let me start all these switches.
Okay.
Okay, so in this condition, if I'm taking console of these devices, so if you will come to switch 1, so spanning tree, I'm the root, switch 1 is the root, right? For him,
Yes.
okay, the process is going listening, learning. Okay, now they have gone for forwarding state. Okay, all is in forwarding state now. So my
Yes.
port is only E0 by 0, this one only E0 by 0, right?
Yes.
Okay, so now tell me, if I'm comparing the first option, so the first option is cost is say is 100.
Wait.
Okay, I'm here. Okay,
Yes.
okay, so let me remove this one. So cost is 100 from both link, right? Then upstream
Yes.
bridge ID, you will say that okay, upstream bridge ID is this one. As if I'm comparing from both, for both the links, right? Okay, now you will say okay, what is the upstream port ID? This is also same. Now, so all the three tiebreaker, right,
Okay.
are used, and all the three breaker is same. So
Same
I'm
here.
confused now, right?
Yes.
Because here is hub, but if there will be switch here instead of hub, if there will be switch, then there is no problem, right?
Yes.
Because switch has everything will be same, but the port number will be different, right?
Yes.
But here is hub, so there is a problem. So at that time, if you have a problem in that, so the selection is by default first. If you'll check here, if I'm coming to switch 2, so spanning tree, see, the selection is by default. E2 by 0 is block, okay, and
Yes.
E1 by 0 is this one, right? Okay, now tell me which one is lowest. E1 by 0 is lowest or E2 by 0 is lowest?
E1/0.
Yes, so here in this condition, if everything is tie, so the fourth one is
The port sender.
lowest port
Sender.
ID of local
Okay.
switch will be considered, will be used as a tiebreaker. Okay, it will be used
Okay.
switch is now root port. So what is my local port ID? Lowest E1 by 0 or E2 by 0?
E1 by 0.
E1 by 0, of course. So if it is E1 by 0, so you can see here E1 by 0 is my root and
Root.
E2 by 0 is,
Block 1.
okay. Now you will say, no sir, I want to make this E20 by as a root. No problem, come here, interface E2/0, spanning tree, VLAN 1, port priority, let me make 64, right?
Okay.
By default it is 128, but let me make 64. Come here, so a spanning
Okay.
tree, see, E2 by 0 is block,
Yes.
E3 by 0 is sorry, E1 by 0 is root. But remember what I told you, when you change the condition, come here, E
Okay. No shut.
interface,
Shut.
no, together, interface range E1
Okay.
slash 0 and
Yeah.
E2 slash 0, right?
Okay.
Together, because sometime shut and no shut.
Not.
Yeah, because if you'll do together, then it will be okay, otherwise there will be a
Okay.
problem. Okay, now so a spanning tree, now see, E2 by 0 is
Root.
root, E1 by 0 is block.
Block.
Okay, alternate. So did you understood?
Yes, because this one is decided by the local one.
Yes, but this is in rare case.
Okay.
You will never find these type of things in the network. Who
Yeah,
is using how?
nowadays, yeah.
Yes.
Nowadays.
Okay, so here you can say, for both interface of switch 2, the received bridge ID is same, the received cost is same, the received priority, port priority is same, MAC address is same, port ID
Yes.
is also same. So in such case, switch 2 will check its own interface number. The lowest interface number will become RP, root port, and the highest interface number will become block port. And if you want to make any changes in this, so you can make any changes like that, and the lowest will become as a root port, like that, right?
Okay.
Okay. Now remember, port ID is the last tiebreaker STP will consider. STP determines root and designated ports using the following criteria. Yes, lowest path, cost to root bridge. Now understand.
Yes.
Okay, if you will get some questions like this, lowest
Okay.
path cost to to the root bridge. So
Yes.
the interface will be what, DP or RP or block? Lowest
RP.
path cost to root bridge, very good. Lowest
Yeah, RP.
bridge ID,
Yes.
okay, lowest bridge ID,
Yes.
okay. So if path cost is same, then I will look for bridge ID, okay.
Yes.
If bridge ID is also same, then I will look for sender
Lower
port
sender.
ID. If sender port ID is also same, then I will check my own port ID, right, own local port
Okay.
ID.
Yes.
Okay, now summary of STP operation. Following three steps summarize this steady states operation when nothing is currently changed in STP topology. Okay, so the root criteria, the root creates and send BPDU message, that I know, in STP with a root cost of 0. Yes, when I am root, I will tell you that okay, to reach me is 0, right?
Yeah.
So
Yes.
this we have already
Yes.
discussed. Non-root switch will
No.
receive the hello packet on their root ports. Okay,
Yes.
step 1 and step 2 will be continuously running in your network. Now designated port identification, practice topology. Okay, so you make this topology. Okay, I have the soft copy, if you means the raw copy of this one. Okay, so
Okay.
I, if you want, I can send you through WhatsApp, so you can check, download this one. Okay, the topology is there is no any changes. So you just open
Okay.
these switches like I have it. Open, save file, open, desktop, Amadu, all STP process. I deleted or what?
Something like
Maybe I deleted that.
mm,
Okay, no problem. This is how I deleted. Maybe by mistake I deleted that topology. Be- because when I was making this lab, I okay. See, it's very simple.
that.
Yesterday we have discussed on this. If this is a root switch, right? Okay,
Yes.
so first you make this topology on your system, and if you have any
Okay.
problem you can ask, or you can ask now also, that why,
Okay.
what is the status of this port. I can tell you now, in just, instead of checking from so spanning tree, it's very easy.
Okay.
See,
Okay.
by default you have this root switch with the help of
Yes.
lowest bridge id, right?
Yes.
Now all port will be designated, right? Now come to
Yes.
switch 2. Switch 2 has how many interface, tell me?
6.
6.
Yes.
Gig 1, gig 2, F22,
Yeah.
F21, F23, F24, right?
Yes.
Okay, now from switch 2, if you want to reach root, which one is the lowest one? Which link can r- help you to reach root? This 2 link, right?
Yes.
Okay,
0 here.
now in this 2, I have to select which one will become root port, right?
The root port.
Okay,
Yes.
so I have to consider from upstream switch. So this is what? Gig
Yeah.
1, gig 2. Okay, so
Yes.
which one is the lowest from upstream switch? This
Big,
gig 1.
big,
So
big
of
one.
course
Yes.
this one will become root port, right?
Yes.
And here is what? Designated.
Yes.
Okay, now here is designated, and here is what? By default,
Block.
no, by default
That is
designated, right?
designated to.
So
Yes.
designated cannot be same, so they will compare
So.
whose MAC address is lower. So I'm root, I'm the
Yeah.
best, so your is block, right? Now I
Yes.
am switch 2, so I have one port root, one port is disabled, no problem, block. But other port will
Yes.
be in a designated. Why? Because if you'll compare with other switches like switch 3 and switch 4, those
Yes.
switches MAC address is higher than me, so of course my port, it will be in designated. So
Yes.
in front of this, okay, now see, now
Yes.
come to switch 3. Switch 2 has done. Now switch 3, this is my switch 3.
Yes.
Now if I'm coming to switch 3, to reach switch root switch, this is the lowest path cost, so this is my root port, right?
Yes.
Okay, in by default consider all the ports as a designated first time,
Yes.
then it will compare.
Yes.
Here is dp, here is dp, so one is block.
Yes. They cannot check.
Yes, one is block. Okay, this is block. Now if you are comparing here, this is block because I am 3 and you are 2, so your MAC address is higher, so I am block. Here is block, but here will be dp because my MAC address is higher than switch 4.
Yes.
So any, do you have any question in this, or we can go
No,
ahead?
this one. No, this one is okay.
Okay, so you can do
Yes.
practice, you can explain if I will
Yeah.
ask from you.
Yeah. I'll do practice later, and then if I block someone, I'll ask you.
Okay,
I'll come on it. So.
now changing in stp spanning tree topology, each switches rely on these periodic received hello from the root as they, as the way to know the its path cost and whether the route is still working or not. So every time the other switches in the network, they will be receiving hello from switch or non root switches. Okay, with, and
Okay.
why, what this hello packet is including the root switch information as well as our topology information, right?
Yes.
Okay, so now when a switch fails to receive hello, it knows a problem might be occurring in the network. So if I'm, maybe I'm a non-root switch, and if I'm not
Yeah.
receiving any kind of hello BPDU message, then I will consider that there is a problem in the network, right? When a
Yes.
switch stops to receive a hello or receive a hello that list different kind of details of the network, so in that case also I will understand that there is some, there is some failure in the network, or maybe some links is down, or there are some changes. Okay, so switch reacts and start the process of changing the spanning tree topology. Okay, so it
Yes.
means it will start like listening, learning, and it will look and it will
For the
converge,
next.
yeah, or it will reconverge, and then it will make a new topology with the help of yeah,
BBG.
new BPDU messages.
Yes.
Normally, when we are talking about STP port states, so STP runs with different type of port states. Okay, so for that
Okay.
you have to take listening, learning, forwarding, all those things. Where is that? Where is that? Okay, this is the best option. Okay, now
Okay.
see when I'm starting my switch. So see here, if you'll check my this topology, not this one, before this one. Okay, maybe let me open packet tracer. I have the login ID of this one. That's why you will not see login. You know when you will open packet tracer. So
Yeah, okay.
yeah, I have already logged into this one. Okay, now what I wanted to show you. Okay, let's take this, switch this one, connect the link, connect the links. Okay, start CLI, enter, no, so spanning, so
Never.
spanning tree. Okay, see when switch port was what? The port was blocked or off. Listening, then they will go for learning, and then they will go for forwarding.
Yes.
Okay, so I mean to say here, when I connected a switch or when I started the switch, so the port was blocked or disabled.
Disable.
Disable, very good. Okay, but here this port is what? Is it a disable or block?
This port is blocked.
No, yeah, very good. This port is blocked, right?
Yes.
Okay, now, so when any port is blocked, so spanning tree, okay,
Yes.
okay. So when any port is blocked, so the condition is different in that condition, okay.
Okay.
So spanning tree, okay. So in
Okay.
that case, condition is different, but when the port is disabled, in that case, the
Yeah.
timer and the hello is different. So
Okay.
let's understand here with this scenario.
Okay.
See, if port is disabled, means the switch is new, right?
Yeah.
Okay, so in that case, your switch port will take 30 seconds to come in
Forwarding.
forwarding state. See, disable is disable, right? So when you will
Yes.
on the switch, it will directly go for listening, which is okay, LSN.
Yes.
Okay, and this listening will take 15 seconds. Okay,
Okay.
to do his work. I will let you know what they are doing here in listening. And after listening, they
Okay.
will go for learning. Okay, and that is also 15 seconds LRN. Okay, and
Okay.
after that 15 seconds, then they will go for forwarding. So from
Okay.
disable to forwarding, okay, the port has taken how many seconds?
30.
30 seconds. Now but if I'm talking about blocking,
Okay.
okay, now tell me, so the blocking is default, or there are some process to make the port as a blocking?
There's some process.
Yes, so STP has blocked that port with the help
Yes.
of like some kind of conditions, right?
Yes.
Okay, so
Yes.
from blocking to listening, okay, it
Yes.
will take 20 seconds,
Okay.
and from listening will 15, and this is 15. Okay,
Okay.
15 and 15, so total is 50 seconds to become in
56.
forwarding.
Okay.
Okay, so now I told you here about this. Okay, so now, so there are 5 stages through which a switch
That's the
has to
first.
pass, okay, the full conversion state of the port, right? So a
Okay.
spanning tree transition each port through several different stages. Okay, see when the line come ups, right? So
Yeah.
line come up means it when it was disabled, right?
Yes.
Okay, see there are two type of condition to become line. okay, line is down. Maybe it can be a
Okay.
blocked or maybe it can be disabled, right?
No, yes.
Okay, so if it is blocked, so from blocking to
Okay.
listening, so it will take 20 seconds first in blocking, okay,
Yes.
and that 20 is the hold down time of BPDU message. Remember, see why
Oh
I am
yes.
blocked, because I am receiving some kind of BPDU message to block me, right?
Yes.
But
Some
if,
instruction.
yes, but if I will not receive the BPDU message for last 20 seconds, then I will say, oh my god, there is no one, so let me make my port up, right?
Yes. Yes.
Okay, so so I will wait 20 seconds, okay, and then it will go for 15 seconds, then 15, then forwarding. So it 50 seconds if the port is blocked. But if the
Yes.
line came up and the port was disabled, then it will take only 30 seconds.
30 seconds. Yes.
So disable means the port is in a down state, no receive
Yeah.
any BPDU
By
traffic, of
default.
course,
Yeah.
yes. A port disable state has been administratively down, right? Maybe if I will
Yes.
down manually, right?
Okay.
Or maybe by default it is down. So a
Yes.
disable port does not forward any kind of frames, okay,
Mm.
or it do not participate into STP
Yes.
conversions. STP must initially assume that a loop exists in the network, so a broadcast storm can form in a seconds, okay, and
Mm.
requires physical intervention to stop, right?
Okay.
So see, now assume, you have to assume, okay, so maybe if you disable some port manually, okay, maybe like instead of blocking, see STP is blocking man by default, right?
Yes.
Okay, so if you also want, you can block physically also. Instead of blocking, you can down it also, shut down.
Yes.
So if you shut down also, the STP will not create any kind of sorry, there will be no loop and there will be no
No.
need of STP, right?
Okay.
So why we need STP? So STP is a manual or sorry, automatic process, right?
Yes.
Okay, so we want automation in our network. So maybe the link to which we have blocked or disable it manually, and that link and the link which is working, maybe the working link is down, right? So and
Yes.
this link is down manually, right? So your
Yes.
network is down, right? If maybe you have this link which is working link, right, and this is
Yes.
also working link, but to stop loops you disable this manually.
Okay.
Are you understanding? I disable
Yes.
this link as a manually, but due to some link problem, this link is down. Do you think that
Okay.
this link will come up?
No. No.
No. That's why we need STP, right? STP
Yeah.
will down, block, or up manual, sorry, automatically, right?
Everything. Yeah. Everything is automatic.
Yeah. So here, the STP will always take a proactive approach, starting in a blocking state. Okay. Allow STP to complete its convergence process before any traffic is forwarded. So
Yes.
you will see that when STP will start, right,
Okay.
to enable the port, okay, so it will start from blocking state or it will start from disable state.
Disable.
So don't think that STP process will start from learning state or listening state like that, right? It will never start from there.
No.
It will start from
Okay.
disable or blocking. Okay.
Okay. Okay.
Now blocking, so the switch port is enable. Blocking means it is not disabled, okay.
Yet.
Yeah, it's enable, but there is no traffic
Okay.
forwarded, okay, to ensure that a loop is not created. Of course, means I'm not sending anything, but I'm blocking means I will receive. Are you understanding?
Okay. Yeah. The
Blocking port
BPG.
will not forward any frames, but blocking port will learn BPDU messages from other switches, and
Okay.
blocking port will not create any kind of information in the MAC table.
Yes.
Okay, all blocking ports will still listen the BPDU messages from other switches, and
Yes.
in the BPDU messages they learn about the topology of your network, and
Yes.
if the blocking port will not receive BPDU message for 20 seconds, then they will move for
Listening.
listening. Very good. Okay, so a port will then transition from a blocking to a listening state, a switch must believe that a port will not be shut down. Because
Yeah.
see, if you are in listening, right?
Yes.
Okay, so it will not go for shutdown to
Okay.
eliminate the loop, right? So automatically they will select whether it will be a root port or designated port, because he has already passed these two information, right? Disable or
Yes.
blocking. Now say
Okay.
that, okay sir, after listening, okay,
Okay.
after listening, do the port can go for blocking or disable? No.
Okay.
If the port, see, if switch wants to block anyone, right, after
Yeah.
disable it, immediately it will block. It will
Block
not
it.
go for
Yes.
listening learning. See, let me show you. If this is a switch, right,
Yes.
this is our topology here. Let me take the new topology. Stp cost. No, this is a big one. Stp port change cost. Stp port ID selection. What about the topology? Where are the topologies? Okay, no problem. We can make one new topology if it is not responding. Then suppose I have this. Okay, it was there.
Yeah. That's a little bit big.
Yes, yes. E1 switch 1, switch 2. See here. So spanning tree. This is a root, right? So for him everything
Yes.
is okay. So the
Everything
process
is
is, yeah, the process is going here, listening, learning kind of thing. Okay. Conf t, no, no, I'm deleting some VLAN. No VLAN from 2 to 1001. So spanning tree. Okay, fine. So all port is in forwarding state. If you're coming here, so spanning tree. Okay, let me delete VLANs. No VLAN 221001. So spanning tree. Okay, so they have selected the root port and alternate port, right? Okay,
yes.
now for example, if I'm connecting a new link, right, like
Okay.
3 by 3 to 3 by 3, now tell me, do you think that some process will run? No, I'm just asking, what is your idea? What do you say? That if I'm connecting a new link, do you think that some process will go or something like that?
No,
See,
no, nothing will go.
by default port is disabled when I will
Yes.
connect, right? And if you are coming here, see here, so spanning tree, 3 by 3,
Mm, yes.
3 by 3, where is 3 by 3?
3 by 3 is not there.
Maybe I
Yeah,
made
here.
it. No, here is there. Okay, no problem. Let me delete 3 by 3. Let me take 2 by 0 to 2 by 0. Okay.
Okay.
I connected and I came here, switch 2.
Okay.
So a spanning tree. See, 2 by 0. Why they are not?
Here there is no two zeros.
So interface trunk.
Yeah, two by
Let me.
zero is here.
No, no, no,
Here
no.
there's two by
Yeah,
zero.
yeah. Because let me take new lab, okay? Because
Okay.
when you have old labs, what you have configured. E0, E1. So spanning tree. Listening learning is going. Let's finish the listening learning. Learning forwarding.
Okay.
Switch to so spanning tree. Okay, so E0 is root and E1 is block, right? Okay. Now, if I'm coming here and I'm connecting a new link, which is 2 by 0 to 2 by 0, right? Now come
Yes.
here and check. See, 2 by 0. Do you think that any process is going on? No, it's directly blocked. No listening, no learning.
Yes. Yes.
Why?
Because the decision is was already taken, or the
Yes,
process already.
yes.
Yeah.
So here it is saying that if the port is disabled, after disable your port will go for blocking, or if it is not blocking, then it will go
Yes.
for
Listening.
listening learning. But if it is blocking, then blocking. Okay.
Okay.
Okay. So listening learning we have seen. Then the switch can now send and receive BPDU messages to participate in the election of root bridge, root port and designated port. It cannot forward any network traffic till now because they are negotiating, and these root port selection is going on, right? Root port, designated
Yes.
port. Okay, if listening port is not elected as a root or designated port, it will transition back to
Block state.
block state. Now after listening, in listening what they were doing, listening they were send and receive of BPDU, but they were participating in the election of root bridge and root port and designated port. When the listening is done, then they will go for learning. Okay, if a listening
Yes.
port is elected as a root or designated, it will transition
Yes.
to a learning state. Okay, a port must wait a brief period of time like 15 seconds. Okay,
Yes.
yeah, referred to as the forwarding delay. Okay, forwarding delay means to become a forward. Okay, 15 seconds
Yes.
before transitioning from listening to learning. A learning port will continue send and listen the BPDU messages. The port can now learn the MAC address and modify
And
the MAC address table here. But in
yes.
listening state, they will work in a transition state to become what I am, whether I am root port, non-root switch, whether I am root switch, whether my port is root port, designated or block. But here in learning, they will
Yes.
send and receive BPDU, and in that they will start making the MAC address table. Okay,
Yes. Yes.
okay. And but here switch will still do, they will not forward any kind of information till now. Okay, but when they
Okay.
will move to forwarding state, after forwarding state they will start sending and receiving of data as well as BPDU messages.
Yes.
Okay, now after this stage also, listening, learning, forwarding, there are some stage which is known as
Broken.
broken. Okay, so what is broken state? See here. Note, STP can also have the sixth stage as well as what we have known. So okay, it is known as broken state, which is known as BNK. BLK is
Okay.
block, BNK is known as broken. But
Okay.
how it broken will work? Now let's make some lab like this. See, if a switch, this is working in a access port and this is working in a trunk. So there will be a
Okay.
mismatch communication, right? I'm access, you are
Yes.
trunk. Okay.
Yeah, they
So
cannot
in,
communicate.
yes. So okay. So let's make some lab like that. So let's delete some ports. Delete, delete. Now no problem. Okay. So if what I will do here, I will come here on switch 1. Port is E0 by 1. E0 by E0 by 1. No problem. Here also E0 by 1. No problem. Okay. It's okay. Listening. See, now it will take 50 seconds. Why? Because it was block, right?
Yes.
Yes. Now listening, then learning, then forwarding. Okay. So now E0 by 1 is in a forwarding state. E0 by 1 is a forwarding state. Now, if I'm coming here to switch 1 and I will say conf t interface E0 slash 1 switch port trunk encapsulation dot 1q switch port mode trunk, right? And here
Yes.
manually, instead of negotiation, I will come here in this e0
Put
slash
some
1,
access.
yeah, switch port mode access.
Access.
And then see, now just wait for some. See, you're getting some kind of inconsistent
Error.
port type, right? Okay,
Yes.
see this block port is blocked, right? But which type
Yes.
of blocking is this one? So if you'll come and check here, so a spanning tree. Okay, still it is learning. Just wait for. Okay, here it is forward showing forwarding. Let's see here. So a spanning tree. See here, BKN.
Yeah.
Okay,
Okay.
BKN
The
means
broken one.
broken
Broken.
due to some kind of problem. But what is the problem? Problem means a switch port enters in the inconsistent mode. Okay, and maybe the port type will be mismatched. Maybe you are trunk and I am access, or maybe the
Yeah.
native will and mismatch will be there, right? Or maybe
Okay.
encapsulation is different. I am using ISL
Yeah.
encapsulation and you are using
Dot one.
2.1q encapsulation, right?
Yes.
Okay, so this is the port inconsistent type. Now STP port type, see, you can do this practice, but I have shown you, right?
Yes. Yes.
Okay. Second, STP port types and role. See, there are three types of ports in STP, whether the port will be designated,
Designated.
root, or block. So blocking has two mode. One is blocked
Broken.
by STP and one is BNK, right? Broken link.
Yes.
Okay. We already know about designated port, the work of
Yes.
designated port, right?
Yes.
Okay. The work of root port and why
Yes.
it is blocked,
Yes.
and how I will know designated port is this one. Block port is
Yes.
alternate block, means it
Negative.
is
Yeah.
temporary block for some time. Okay.
Yes.
Okay, so only two type of port will be working in a forwarding state, which is root port. Okay, so root port will be working in a forwarding state, designated port will be working in a forwarding states, but
Forwarded. Yes.
alternate. And see, if you
Um,
see
uh,
this one also, see this is, can you see, I'm on switch 2, right?
yes.
Port is in designated, but it is
Yes.
blocked. But why it is
Yes.
blocked? Due to some inconsistent port type. See this type
Yes.
inconsistent, right? So the switch is not able to decide the whether I will be working as a root port or designated port or something like that, right?
Yes.
Yes. So so you can see here stp timers. Okay, so stp timers we will be working in a next class. Okay, we will
Yes.
talk about timers and we can change the timers also, but already we know about some timers that hello is 2 seconds. In every 2 seconds switch will send hello message to another switch, right, informing that yes, I am alive in the network. Okay,
Yes.
and there is 15 seconds, or you can say it is 30 seconds. Okay, 30 seconds. Not
Yes.
forward delay is divided into two section, listening and learning. So listening is 15 and learning is 15, right? And
Yes.
max age is 20 seconds. What is max age timer? Max age means if I am blocked, I understand it.
Yes.
If I am
Yes.
blocked, so after how many
20
times I,
seconds.
yeah, I will
Yes.
move to other transitioning states. Okay,
Yes.
so this I have already explained you about the timers. Okay, so
Yes.
the same thing you can, if you want, you can, when I will share these slides with you, you can go through it. Same thing what we are talking.
Okay.
Okay.
Yes, I can see.
Okay, so in our next class we will see how to manually change our timers. Okay, as we know that
Yes.
our STP is working as a per VLAN STP, right? Okay,
Yes.
so even if you want, you can change the timers of different VLANs. Okay, so uh,
Okay.
for VLAN 1 my hello is different, but VLAN 10 my hello is different. Okay,
Okay. So in the company, do they used to change the time, or is something that is normal to leave it in the default one?
no, it depends on your switching capacity. If your switch is
Okay.
high end switches, so in that you can
Okay.
change the timers.
Okay.
Okay, so
Right.
in our next class we will be knowing how to adjust the STP timers.
Cool. Okay.